Bismillahirrahmanirrahim. Welcome to PMTC online lecture room. Today students, we will discuss a topic from chapter Chemical Bonding of first year textbook, that is bond characteristic. In this lecture, we will discuss two important characteristics of bond energies and bond lengths. First, we will discuss bond energies. Before going into the detail of bond energies, you must know that whenever a bond is formed between atoms, then energy must be released in this process. And the same amount of energy is absorbed when we break a bond. So, bond formation always release energy and bond breaking required energy. This energy required to break a bond and form neutral atoms are called bond energies. Bond energies depend upon certain factors like electronegativity of two bonded atoms, size of an atom, and bond length. We will discuss bond length in the same lecture with detail. Greater the electronegativity difference between bonded atoms, greater will be the bond energies and vice versa. Higher the bond energies, stronger will be the bond between atoms, and of course bond length will be smaller. Similarly, lower the bond energies, bond will be weaker and bond length will be larger. Now you can understand that bond energies are inversely related to bond length. We can explain this by taking the example of carbon-carbon single, double and triple bond. Triple bond is stronger than double bond, which in turn is stronger than single bond. So bond energies of triple bond is greater than double bond, which is greater than single bond. So their bond lengths follow the reverse order as you can see on the screen. As we have discussed that bond energies depend on certain factors. So to understand that, we compare the bond energies of some molecule, for example hydrogen, chlorine and HCl molecule. For example, energy required to break one hydrogen-hydrogen bond is 72.42 into 10 power minus 23 kilojoule. It means that bond energy contributed by one hydrogen atom is 36.21 into 10 power minus 23 kilojoule. Likewise, bond energy contributed by each chlorine atom is 19.73 into 10 power minus 23 kilojoule for chlorine molecule. So from these bond energies, we can expect or calculate the bond energies of HCl molecule, which is 55.94 into 10 power minus 23 kilojoule. But the experimental value or real value for HCl is 72.39 into 10 power minus 23. So why do the experimental value vary from expected or calculated one? Here is the reason. Because of electronegativity difference. The HCl molecule is polar and is stronger bond than non-polar molecule due to difference in charge distribution. These unequal charge distribution or unequal sharing of electron give additional binding energy to the atom or bonds. As a result, the bond become more stronger and experimental value exceed from expected value. Greater the charge difference, greater will be the bond energy. Here is the comparison of different hydrogen halide. We know that fluorine is most electronegative atom. So HF is most polar due to difference in electronegativity, greater difference in electronegativity. So the difference between calculated value and experimental value is greatest for HF, that is 274 kilojoule per mole. As we move downward, the electronegativity difference goes on decreasing and polarity of the bond also decreases. So the difference of bond energy also go on decreasing and is lowest for hydrogen iodide, that is 9 kilojoule per mole. The second important characteristics of bond is bond length. What is bond length? How do we measure it? So bond length can be simply defined as average or mean distance between nuclei of two bonded atoms. For example, in this diagram, R1 is the radius of smaller one and R2 is the radius of R1 is the radius of big atom and R2 is the radius of smaller one. So the bond length is the average distance between R1 and R2. Now come to the measurement of bond length. So for measurement we need a unit. The unit in which we can measure bond length of bonded atoms are angstrom, nanometer and picometer. Generally, we use angstrom to express bond length, but picometer are also used sometimes. How can we determine the bond length of homonuclear diatomic molecule? Simply, it is the sum of radii of two bonded atoms. For example, if we talk about carbon, then covalent radii of carbon is 77 picometer, which is half of bond length of carbon-carbon bond. Likewise, covalent radii of chlorine atom is 99 picometer, which is half of chlorine-chlorine bond length, that is 198 picometer. Now come to the bond length of heteronuclear diatomic molecule, that is bond length of different bonded atoms. So for heteronuclear molecule, the calculated value of bond lengths are always higher than experimental one due to difference in electronegativity, which produces polarity and results in shortening of bond length due to greater forces of attraction between polar bonds. From the table, you can see that for R hydrogen halide, the experimental values are smaller than calculated one. If you look at the difference between calculated and experimental values, then you can observe that the difference is greatest for hydrogen fluoride due to higher difference between electronegativity, because we know that fluorine is most electronegative atom. I hope you understand this topic. Here is assignment for you. Why bond energies of polar molecule are greater than non-polar molecules? Compare the bond length and bond energies of hydrogen halide. Thank you.